For those of you who had a chance to start eating, you can keep eating until you finish, but our speaker will start soon. He comes to us, well, he's a Gainesville native. He has 2 degrees from Georgia Tech, a bachelor's in civil engineering in 1990, and then he gets a master's in 91. That was pretty fast. He's been a PE since 1995. He is the, says there, State Bridge Engineer in the Office of Bridge Design for Georgia Department of Transportation. He travels from Loganville every day to work, and I asked, well, how many bridges do you go over? He says, I don't know. So welcome.
What's that?
Welcome.
Oh, thank you. I appreciate you having me. It's kind of interesting. You know, I am familiar with this area. As I was going to Georgia Tech, I went to, let's see, I lived off of Montreal Road, which is just right around the corner on the other side. So I knew exactly where this place was, but Roger said, you know, try to get here before 6, you know, maybe a little before. And so I'm working and, you know, just make sure I know what's going on. I pull my phone out and I plug in, you know, what's the fastest route here? They said, go 78, go to 285, come up to La Vista. I'm like, all right, I can do that. But I'm looking at the alternate routes. You know, I-20 out to 285 was about 5 minutes longer, and then I looked at 85, and it's like, well, that's not an option today. So anyway, but Google was not quite right this time. Took me down to the wire to get me here at 6 o'clock, but I'm glad I finally made it. So I guess to start off with, you know, I'm going to talk about the bridge today, and certainly I have time for questions as we go on. But just you know, this is one of those things. You know, I'm going to remember where I was on March 30th, 2017 for quite a while, I do believe, and I can tell you exactly where I was. So you know, my normal day, because I like to avoid traffic, I get up and get to work at about 6:30 in the morning, and I carpool, so we leave pretty regularly right around 4 o'clock, so we can get on I-20 and get out of town as smoothly as possible. So I get home and I do my normal, you know, that night I was working in down in my shop in my basement, and my son was out cutting the grass, and staying on top of him, that was great. I'm glad he finally got the grass cut, and we finished all that up, and then I promised him, I said, well, we'll get you a hamburger. He's a 17-year-old boy, he runs track, and ready to go eat a hamburger. So we left the house, got on 78 right in Loganville. You know, it's a 3 miles away from the house. And I turned on I had WSB on. Now, that's a miracle because my son's in the car. He's a 17-year-old boy. I mentioned that already. And Mark Aram's on, and Mark Aram's talking about, you know, there's this fire under I-85. It's like, okay, that's interesting. And we drive a little bit further, and he says, you know, I've never seen anything like this. And you know, all the traffic reports he's done, I've never seen anything like this. This is really bad. And then at one point he said, I think there's a gas station underneath the bridge. And I'm sitting there thinking, now, I mean, all right, I've been around a while. I can't remember a gas station being under that bridge, but I couldn't remember exactly what was under there. So listen to him. He's got the black smoke coming out. So I tell my son, I said, you know what? We're cutting this trip short. We're going to wheel into McDonald's. We're going to grab us some takeout, head back to the house. And I just ran in because I had to change clothes real quick and head back to the office. So my son said, okay, I want to go with you. And I don't take him to work. You know, that's not something we normally do, but this is after hours and all. I knew there's something going on, but I said, yeah, sure, come on, let's go to work. So he hops in the car with me, and we go ahead and head to the office. Well, I guess I will say, now, I guess I missed one part in there. I did talk to my state bridge inspection engineer, Clayton Bennett. I talked to him in that conversation, and he said, yeah, he had got a call from TMC. It does look like it's pretty bad. So he was organizing bridge inspection crews or other bridge inspection engineer and team to get there to go head to the site. So we're all on the same page. But anyway, back to the story. I'm heading back to the office, counterflow, you know, everybody else is trying to go home and we're trying to get back into Atlanta. But traffic's, you know, this time it's, I don't know, it's probably in the order of 6:15, 6:30. I don't exactly remember the time it was, but it was somewhere around there. And my son's with me. And my phone is just blowing up because that's just what's going to happen. And so he's got my state phone. You know, I got my personal phone here and I carry my state phone here. And he's answering text messages for me. He'll say, oh, this came in, and I'll say, okay, do this. And then he'll say, here's a call. He'll hand it back to me. So one of the first people I talked to was another one of my assistants, Lynn Clements, and she's on the phone. She lives down in Middle Georgia. And she's starting to, here's what's going on. She's calling other people to start looking for plans to see, you know, what information we have available. And I hang up with her. I talk to Mike Garner, who's one of our bridge construction liaisons. So, or he's a construction liaison, but he's also he's got a lot of experience, a tremendous amount of experience in bridges. And he's down in kind of, I believe he was around maybe in Taylor County, and he said, you know, I think I'm gonna head that way. You know, we're just automatically starting to migrate to Atlanta. And but anyway, going down the road, my son gets a text, and the text is the span has collapsed. And he's got the other cell phone going, and he's got the video up, and yeah, we see what's happening. And then I know it's really bad. It's still bad. So, you know, I had a little bit of time working my way to the office to kind of think about what's going on and contact some other people. I also have a federal partner for Federal Highway. We have every state has what they call a division bridge engineer. So I'm calling the Federal Highway Division bridge engineer and saying, okay, are you aware of the situation? You need any communication, anything from me? You know to call me. I'm here. I'm open because we need our federal partners. It's an emergency. It's an emergency event, and then we rely on working closely with the feds to analyze the situation and capture those emergency relief funds. Now, I'll also say this is the only part of the fire you'll see. This is you probably have seen. This is there is an active investigation by the NTSB. So I will not talk about. All I'm going to talk about tonight is our response and the reconstruction effort. So that's just all I can say. Let's see if this works. Okay, so this is not anything special. Well, that related to the fire, except this is our transportation management center, which is located off of Confederate Avenue down near the zoo, and it also houses you might have seen this on the news. It houses our ATMS traffic cameras. So all the traffic cameras that are fed around it in the metro area are fed into this, and they can monitor and control. They can notify the heroes in response. So that's what all happens out of here. Well, at the same time, this building is right next to the GEMAs in the State Operations Center. So when events occur in the state that impact us, you know, the first thing that we do is we mobilize at the TMC, and we open up a room, and we have, you know, it's our kind of our war room, and we have, you know, senior management will come in, operations people, maintenance, that type of thing. And then if it gets to the point that it's other agencies are involved, then they'll migrate over to the State Operations Center. Honestly, I don't know which one was open during the event. All I know is I was at One Georgia Center, which is off of North Avenue. That's our main office. And all I did is I just contacted back and forth. I just called the phone number. So, but anyway, that's what happens. We mobilize, and that's where kind of the nerve center of all the activities going on. Of course, now I'm a bridge person, so my focus and the focus here is primarily on bridges. But in an event like this, that's really only a piece of the entire puzzle. So you're probably all familiar with the site. Here's the This is 285, excuse me, 85 northbound, southbound. This is span 30 northbound. This is the actual span that collapsed. And Buford spring connector is right next to it. One thing that, kind of interesting, I mean, you kind of look at it, I mean, 85 kind of sits up at this elevation. Buford spring connector kind of sits, down a little bit lower, but it's still not all the way down. So to me, it looked like there's kind of a high bank along Buford spring connector where it kind of dips down up. So what did we do there? There we go, back. Where it dips down under the bridge a little bit. So it looked to me, just from what I saw at the fire, it looked to me like as this fire was going, it just looked like the fire kind of migrated this direction. And that's what we ended up seeing. We had damage. Obviously, this span was down. We ended up having to replace this span, and then all in these three spans as well. But it looked like the fire kind of headed this direction where it was open out in this area. About certainly not the first night. First night you couldn't get down there. I mean, but this is probably demolition starting on the 30th. The event happened the night of March 30th. So this is either first early in the morning or later that evening. I don't know which one. It was probably early in the morning, but I know at some point during the night, because of the materials that were down, they were still burning. The contractor had to come in there and kind of open up and kind of vent it so that the firemen could still put the fire out.
So when did you let your first contract?
So, good question. They were all right. So I went straight to the office when I got out to the site at probably 1 a.m. in the morning. C.W. Matthews had already moved on, and they were setting up. They were setting out traffic control. They were setting out what we call light plants to light up the site. And then they had a sub come in. This is D.H. Griffin, you can see here. They had a sub come in to primarily work on their demolition. Now, in these emergency type contracts, it's two phases. So one of it is the demolition. The other phase is the reconstruction. Demolition, I mean, we can handle it both ways. I mean, sometimes, but in this case, we needed to handle it in two phases. But with the demolition, we can handle it by what's called a force account. That way, they start bringing in everything. We know we're monitoring what they're bringing in to work. And what we have is we have these guys. So this is a DOT inspector. This is actually a Moreland Accountability inspector. They're out there kind of monitoring what equipment's out there, what labor force, and what time they're putting in. And that way once we agree on a price, then all we have to do is work on that total amount, the time that was there. We just pay them for the amount.
So this contract was written before this thing happened?
So, not for the force account, no. And and I'm not sure exactly what point the force account was executed. What we have to know is what are the rates for what are the common rates for that type of work. And then all we have to do is maintain a record of what's out there, and then we just back figure.
So it's an on-call contract.
I don't think it's an on-call contract. It's just set up.
So something like this happened, and then Russell just called up, or somebody called up C.W. Matthews and said, "You guys need to be here."
Most likely, yes.
Yes, okay.
Yeah. Yeah, and it's not something. I mean, we've done this a number of times. I mean, I was telling I think Phil earlier or Steve earlier that we had the fire up on 285 around the perimeter years ago. I mean, we had a couple of contractors show up there, and we have a number of things that happen throughout. We'll have bridges that are impacted, and I had one a year and a half ago out on Memorial Drive where we had a retaining wall fail, and we get the contractor out there, get them in a force account, calculate all the materials we need, and we just pay them back. But that's real handy in this type of application. There again, we did have to work through a contract to get Moreland on board. Moreland came in to do the construction inspection throughout. So yes, I mean, Moreland handled most all of the construction inspection. We had people out there for technical assistance and oversight throughout. That's why you'll see this GDOT guy out there. I hope this thing's still working. Let's see. It is still working. DH Griffin, though, this is kind of this is probably the first light, because you can see all the spans are up except for the one collapsed span. They were hard at it trying to demo that demo the project. I really wanted to focus in on a couple of slides, just so you could. It's kind of hard to see because most of the slides aren't very good. It's kind of hard to see, but you can start making out some of the concrete that we were seeing, where the concrete spall. Well, I'll show you on this part. Now, this is an interesting, and there's going to be a better photo when I get to our image, when I get to some of the sheets that were prepared. But this type of cap's called what we call an inverted T. And so it's a T shape. It's got and the beams sit down on the ledge, and the top of the deck comes in right at the top of the cap there, right over the deck goes right over top of that cap. It's a little bit different than what we normally do. It's typically used for low clearance situations where, if something's going to drive up under the bridge or whatever, you typically will do this type of construction. Well, if you'll notice here, this ledge, this is where the span collapse, that ledge is entirely in place. So, which it suggests that the span just overheated, the strands relaxed, and the span fell, but the beam, the substructure stayed intact. Excuse me? It does. I'll show you bearings as we go on, and there's some dowels, and I'll show you a picture of what those look like eventually. But here you can see the reinforcement as exposed. I mean, this has not been hit by the demolition. This is purely fire. We noticed our inspectors out there. Like I said, our inspectors were on board that night. They were, first of all, you get there, you kind of assess the whole scene, but then you got to wait for the fire to get out. You got to get to the point where, it was smoky. Even when I was there at 1 o'clock, it was just way smoky still. But you got to assess it. You got to be careful because you don't want to go under it if knowing if something else is going to come down. So the inspectors, they were noticing as they got in there, they were noticing that some of the columns were showing signs of buckling. That's when you really get concerned, very nervous. So spans down. We know 85 northbound was out of service. It's when we started seeing signs like this along Piedmont, and knowing and seeing that buckling shape, and knowing that we got a real problem over Piedmont. Just one last final photo. There again, you can see the damage along the pre-stressed beams as well. All of that concrete starting to spall and burn up. The fire will do a job on concrete. It's just as well as steel. So, come back here. All right, so there again, I kind of showed it before, but the green, I don't know why the slide's got green on it, but that's really just shows where Piedmont is. So Piedmont's crossed underneath. Here again is the span that collapsed, and these are the total 6 spans that we ended up needing to replace.
The fire.
It was under here.
It was right there.
Mm-hmm. Yep. So, and remember what I was saying is that Beaver Springs connector is right here, and it looked like the fire just kind of migrated that direction out to where it opened up over Piedmont. That's what it looked like after the fact. So these spans, this is a 92-foot span. This span is 114, and I think this one was 114 as well, 114, 120. Maybe that's a 119-foot span, is our maximum span length. So when I got to the office, had another assistant come in, another engineer, one of my office come in, because there's not a lot to do as we're assessing things, other than basically pull together all the plans, talk to my people that are in the field, and start getting familiar with the plans. And you'll see as we go through this kind of how, if this had been just a routine, if you go, if I go to bent 31, 32 this way, everything's nice and spans are all identical. You know, that would have been, I don't know, better. But in this case, you know, everything's different, and you'll see that as we go.
How many different families did you have?
Six.
Everyone is different.
Yeah, I think these two are probably the only two that were the same. Okay.
Is it just bring up the curvature?
And bridge is in a curvature.
Yeah.
So yep, it's in a curve. So this is what we call a deck section. So this is the deck section over Piedmont. It shows a total of 12 beams. Now this is our drawing. It's not the original drawing. I didn't put that in here. I put what we drew. So, but we matched once we got into it and decided on how we were going to repair it. We matched the beam spacing that was original. So we had 12 beams in this one, but then when you go to well, I'll flip back and forth. So it's 12 beams on the Piedmont side. I'm going to back up a second. This had 12 beams in spacing, and you can notice it's skewed. This span had 11 beams, and then this one matched up with 11. So that's a little bit similar. Then these spans right here all had 9 beams. So it was, and they're all different span lengths. So every one was different. I will say too, as part of the evaluation, you know, the inspectors were out there that night, and they waited. I don't know if you know what happened. But in the middle of the night, kind of things died down. Then they got a little rain shower in the middle of the night. Kind of things cooled down, and then that went away. And the next thing you know, my inspectors are out there, and the fire's, you know, pretty much well contained. My inspectors started hearing cracking. Then they started to hear pops, and so those pre-stressed beams over Piedmont were popping and dropping concrete. So that change in temperature started. Was still affecting, you know, the structure was still undergoing change. Even the next morning when they finally get up there with their basket truck and finally able to get up to it and get hands-on, and what they do is they get up and they take a chip and hammer and they lightly tap on it. They're looking for delaminations. They were chipping on them. Next thing you know, you'd pop and pieces of the bottom flange would fall off, and then they'd pop a little bit more and they'd start seeing cracks just all of a sudden just take off and migrate down the beam. So it's chase, you know, and you can see it because everything's soot black. I mean, it's just black from the smoke. You chip it and the crack goes down, and all of a sudden it's a bright white crack. So they're instantly watching what's going on and seeing what's happening to it, and assessing what the limits of the damage was. So this is a cross-section of the beams. This is the new beams, but I'll just talk about it in general. The beams that were out there are very similar. They were what's called a Type 5 beam. This is a a replacement 63-inch bulb T. Now, what we were doing, another thing that we were doing that Thursday night is I called one of the fabricators, Standard Concrete Products, down out of Savannah, and started talking with the vice president out there, and he's like, "Yeah, I remember fabricating these beams, and those were Type 5s, and they were actually Type 5s that were modified, and you couldn't find that information in the plan. It was good to know, but we don't really use Type 5s anymore. Years ago we went to what's called a bulb T, and that's what this is. It's the same depth of beam, but it's just a little bit more efficient, which actually makes it a little bit lighter. So there's less concrete with these. Well, the issue is those Type 5 forms aren't available. He starts calling around, and not just me. I mean, like Mike Garner he's calling people directly too. We're all kind of working it back and forth, and they're saying, well, there could be some Type 5 forms down in Tampa and their Tampa plant. There could be somewhere else, and we're looking at it going, yeah, why do we want to do that? You know, we have an opportunity now to just. This is what we're producing now. We're putting this in most of the bridges. The only difference is now I got to redesign some beams, and back to where we were. That's with all these spans. It's a total of 61 beams, but I can't remember how many beam designs. I mean, every one of these trapezoidal spans numerous beams because they're all different lengths. Now, not everybody's a civil in here, but you know what concrete is. Concrete's very strong in compression. But what it's not strong is it's not strong in tension. So we counteract that. We put reinforcement in there. Well, with the pre-stressed beam, we put these strands in there. They're high tension cables. Instead of a grade 40 bar, grade 60 bar, they're 270 KSI. So we stretch each one of those strands about 33,000 pounds. You put about 30 of them in there, that's about 900,000 pounds of force that we're putting back into those beams. And so that's what was happening, the existing beams, when that temperature hit those beams and they start unraveling the concrete, those strands started relaxing. And that's really not a good thing. Anyway, so this is the design that we had to work with. You mentioned about the dowel or the bearing. The dowel, we'd have a dowel pin that goes right up in here inside the end of the beam, and that's what keeps the beam in place. And they were there in the old bridge as well. Just to look at.
It was like when was this bridge built? What year?
It was built 83, 84, around there.
Okay.
Yeah, it's not that old. No. But you can see the trapezoidal spans. With the pre-stress force, you know, you put all that force in there. Depending on the length it is, depending on the weight, that force will make the beam camber up. Well, I can't put the same force in this beam as I put in this little short beam. So we had to go in there and keep modifying our design until we worked out every one of them.
How many beams were required for this?
61 total. Yep.
How about the columns?
Columns were in pretty bad shape. They were in bad shape until you got down below ground. You know, once they're insulated from the heat, they were okay. And so we got out there trying to assess what we should do with them. You know, you can't be certain about how good the steel is left. I mean, we felt like the steel. I mean, my confidence level in the steel was shaky. But what we ended up doing is we chipped in, and I'll show you pictures of where the contractor was out there chipping in and getting real close around these existing. This is the existing cage, and they got those bars cleaned up, and then we formed up around them, and we built a new cage, and we poured all around those columns, and that way we just totally encapsulated what was there. And then we had to back up. I'll show you. We also had to come in, and there's a little line right here. It's kind of hard to see. That's where we cut off the old column. And so from here up is all new column. I mean, it's encased. This part's encased, but from there up is all new. Yes, sir.
When you chip away the outer ring of concrete, was there any heat stress on the steel?
Potentially, yes. But we felt like that since we dug down underground, we were able to come in and encapsulate it and capture the lap that was coming up from the footing, and we didn't worry about it after that. Here's the real mess to the whole project. This is that inverted T, and you can see what's in there. There's this the beams would sit. You know, a beam would sit on this side, and another beam would sit on this side, and the deck actually runs right across the top. You have to have, in this type of design, it's really kind of a hanger design that's holding up this ledge, and this was real difficult, and we weighed back and forth. The beams took a while to design, yes. This is the part that I really was concerned about redesigning, and I mean, if we could have redesigned it, we would have. You know, it would have been easier for the contractor, and you'll see photos of where he tore these things down. It was difficult, but if I'd gone back in, the bents along the bent along Piedmont had 4 columns, one size of column. The other 3 bents, you know, they were supporting either 11 beams or 9 beams. Those had 3 columns. There was not any like repetition. You know, I couldn't design one bit and use it for both locations, which, you know, when we're designing a bridge, especially a bridge that's like this at 4,500 feet long or whatever the total length is, I mean, you can do that. You can use different details, but I was not real confident about trying to do that at this point and keep the contractor going, because he needed information. Just like those beams, as we're designing those beams that through the night, through the next day, and so we're feeding that information back to CW, and they're feeding it to their fabricators so that they could kind of be in sync with us. And I hit it off again. But also what was critical is getting the column reinforcement and the cap reinforcement so that they could go ahead and talk to their suppliers and get them ready and get them ready to generate the steel. And I'm going to quit doing this. All right, put that down. So this is we worked, started that Thursday night. We worked all day Friday and Saturday. This was coming up sometime getting fairly late Sunday evening. And this is just part of our team that was there. So what we had done is we'd all been working on, we pieced it out. We had certain people working on beams. We had certain people working on substructure. We had different details. And what we're doing here is trying to pull the plans at that point together. This is another one of my assistants, Steve Gaston. We'd gone through kind of doing our last set of markups to say, okay, here, this is what we want to change. Let's get these down. This is our last run, and let's get these plans completed so we can get them to the contractor. It was actually kind of interesting. I mean, this was almost, to me, it's almost like working a design build project. The designer working for the contractor. Typically, we design, we set it out for bid, and build it, because we're all during this whole process. We're giving CW information. Demolition was going on. We're working on plans. We're feeding them information. They're feeding us information. We're talking with suppliers, not just the beam fabricators. We're talking with. I talked to Augusta Iron and Steel, talking with about the steel diaphragms. You'll see in a little bit. Talking with a supplier for the deck drain system and the bearing pads. Talk with the supplier in Texas with the bearing pads. So it was a constant, just constant communication throughout this whole thing. And also CW had their own engineers. They're working on it. They're back checking us, which was really phenomenal. Yes, sir.
What I was going to ask is how much feedback do you get on how to design the beams to enable the meet the speed requirements that they do?
So, on that aspect, I don't know that I really got feedback. I mean, they were helping us out with details or asking us questions and incorporating. But, we selected the beam type. I mean, and for us, it's a slam dunk. I mean, we know that that's going to work. Of course, the lead time. I mean, that was real important, and that's the contractor. The contractor's who's actually selecting the fabricator. And what do I want to go with one fabricator or do I want to go with multiple? And that's purely up to the contractor. We're just there. Whoever you have, we'll work with them. That's what we're doing.
Where do these beams come from?
These beams came from Standard Concrete. So they have a plant off of. Here in Atlanta off Holiday Road, and then they have a plant in Savannah, and they actually ship beams from both locations in order to meet this delivery. So I will say that I'm pretty proud of what GDOT did. I think we got some good communication out there. Certainly the media was asking us questions. One of the things you see here, Russell McMurray, this is the April 4th press conference. All along, we feel for the commuters, also for all the people in the community involved. I mean, it affects this whole region, and we want this open as soon as possible. We know CW, who is working on this and has been working around the clock. We know they want this open as soon as possible. And but this was one of the press conferences. Russell sitting here. I couldn't get the whole picture in there, but flanking Russell was Meg Perkle, our chief engineer, Mark Masternardi, who is our director of construction, and then on the other side he had Andrew Heath, who's our traffic operations engineer, and then throughout the communications, I mean, they were certainly doing media. They were showing up, doing press conferences. but they were also, you may have seen it on social media. Our communications people were putting out things on social media and trying to keep the public aware. And I think, I mean, as far as what I heard, just feedback in the peripheral, I think we did a pretty good job with that. And I'm really, from my standpoint, this was all going on, and I wasn't up there, so I was real thankful of that. But for the most part, I mean, we had a job at my stage of the project at the beginning. Now, we worked all along. We've been working all along with them, but certainly we had our point was, we're real busy, and then it starts tapering off for the designers. Construction, they've been at it the entire time. But it was nice. The senior management really kept us out of the limelight and let us just do our job, and very thankful for that. You'll notice this. This is go back to the little bit of demolition. This is the span over Piedmont. That was critical. They had to come in there, and what the contractor chose is they put down some matting, and they started working and taking the span over Piedmont down. And we needed to get that down and get it cleaned up so we could get it open. We also worked to get Beaufort Springs open, but some of the things that, I mean, it's like I said, it's not just a bridge effort. This is a GIA effort. Andrew Heath as a traffic engineer, I mean, some of the things that they did were along is they restriped 85 to getting off onto Beaufort Springs. So instead of one ramp coming off lane, they striped it for two to get more people out. They did the same thing back the other direction. They restriped around Sidney Marcus, and they actually, I mean, they even striped up on 285 and 75, trying to help traffic out. And there's some signals down in that area. They helped do some adjustments on some traffic signals, which I know improved, really improved the situation. But that's what we needed. We needed everybody to come together. I mean, you all heard there's 288. Keep saying 285. 85 has around 240,000 vehicles a day in this area. Where are they going? Everywhere. So.
I've seen most of them today.
Yeah.
MARTA should be 5% rise in the traffic.
Mm-hmm.
So that was a good
Yeah. Kudos to MARTA. They were getting out, finding other lots to get people to park in. And shuttle them back and forth. I think that's wonderful. That's great. And not to that I shouldn't fail to mention. I mean, there was kudos on this whole thing. GSPE was out there to start with, helping getting this thing shut down. Our heroes, the fire department out there working. So a lot of people involved in this whole scenario. Sir? Yep. So. So, it's hard to see, correct. So it's hard to see, but let's back up. All right, so that's where the beams sit. So these beams right here span. This is a cross section. That beam spans from one cap to the other. And there's 12 of those in a span, and then a concrete deck lays on top of it.
I see. Okay.
Yeah.
And the bottom plan sets on the bottom corbel of the inverted seat.
Yep. So it's going to sit right here on this part. These are beam seats.
Okay.
Instead of doing it on steel instead of concrete?
No, not at all. So, the lead time for, I mean, we got these beams here, but to redesign that many beams and to have them fabricated in steel, it would have been, don't think it would have saved us time. And that's really, I mean, that's all we're facing with this is time. We're trying to get it done and open this as fast as possible. Yes, sir?
So, doing your redesign, did you use the whole plan for these major dimensions, length of spans and column spacing and all that? Did you redesign all this too?
So, we pretty much stayed with all the dimensions. We had our survey crew out there. So this is my entire time, my total worry in this whole scenario was getting that last beam placed, because I'm worried about where the survey is. Because our surveyors went out and they started spot checking things, trying to line up. And the first indication I got was, well, you know, the intermediate bent's off by 3 inches, and this other bent's off by 7 inches. That's a concern. You know, I'm an engineer, a structural engineer. We typically detail bridges to about the 1/16 of an inch. I mean, that's pretty much where we go. So certainly concerned about the geometry control. But yeah, we used all plans except for the superstructure. We had to pretty much redesign most all the superstructure. We were able to use a lot of the plans. Now these plans, like I mentioned before, this plan set was for a bridge that was 4,500 feet long. So we had to, you know, we gave them the whole set of plans, but we had to pull out the pieces that pertain to this. And that can be tricky when you're looking at, you know, 30-year-old plans and trying to disseminate what's in there and making sure you have everything. And I can say it tripped us up a number of times, but we figured it out. Now,
30-year-old before campaign?
yes, yes, sir. And but at the same time, CW had their surveyors out there, and so, but we kept working back and forth, and everything really came back together on the geometry control. So very, very tickled with that. Just kind of an idea what the site looks like when you're tearing down spans. Like I said, this is it's a mess. Yep. So hard photo to see, but all this concrete, once you get all the concrete down, it takes a long time for these things to they have to rubelize it. I mean, they have to sit there and just break it up. And as they're breaking it up, you'll see, and maybe you see other places, there's just piles of reinforcement laying around, because they break this up and they're putting the reinforcement over here and they're putting the concrete over here, and then they have these trucks coming in. I got another photo at one point where you'll see trucks backing in where they're loading all this material up into the. Good question. They hauled it off to sites. Yeah. Yep. I'm certain the contractor takes over all that, so they get to piece apart whatever they want. But I'm sure they recycled all the steel.
You'll buy that.
Eventually. So actually, this is another hard picture. It's so dark in here, but you can see they actually had to kind of construct. This is coming down from Beaufort Spring Connector. This is kind of a ramp they had to build in to help with the demo. It's not real easy to see. I mean, we still have caps that are up right here, but you can see how there's not a lot of material on the ground at this point. I wish I had the date of this photo, but just to kind of put it into perspective. Now, one of the things that we did that had the contractor do, and this is in the middle of the demo, they got the main spans down, is we had them go back in and pressure wash the adjacent areas. I mean, first, obviously, you kind of want to make it look good when it's done, but the main reason is we wanted to get it cleared off so that our bridge inspectors get back out there and get up and get a good look and make sure that what we are keeping is still good. And so they were out there pretty much every day until that was done, and then once they finally gave us the okay on the existing bents that we were keeping, they were out of the picture at that point. But CW did a phenomenal job getting this cleaned out. This is another photo. So those caps, this is interesting because, you know, as they're working their way down, here's one of those caps with all the reinforcement that I showed you in that one detail, and they've got four machines sitting up there just pecking away and taking it down. And I'm in my office going, you know, no, you can't drop that. It's gonna. Careful, don't cut it off. And they're like, no, we got this. And they really did. They did a phenomenal job taking it down to pieces and not damaging the columns. Just to give you an idea. So this is the caps are gone, but this is interesting. And I know you can't see it, but you might be able to see this little orange line there. And what we did was that's that point I showed you before where we said, okay, we got to cut the columns off at this point and build the rest up. And that was a critical point right there. So that's what this guy's doing. He's holding. I had a video for this, but I didn't bring it because I was worried. But guy's up there and he's got that saw just cutting the column in half. And so as an engineer, when you get out to see these kind of things, I've been doing this for 25 years, and that's fun. That's exciting.
Did they cut the steel and the concrete?
Cut it all. Just cut it in half.
How do you keep the top half married to the bottom half when you put it back?
I'll show you that.
Okay.
So,
It's easy to draw a line and say cut here, but watch this here.
absolutely, yeah. And you look at these caps and you walk out there, and I mean, this thing's got a 4.5% cross slope on the bridge. So if you looked at those caps, they're sloping down pretty good. And we said, okay, you got to cut it. I think it's 9 feet, 8 feet, 10 inches below the existing cap. But when you say, okay, cut it here, the next one's lower, the next one's lower, and you're sitting there going, is that right? Is that right? But it was. It was all right. Yeah, exactly. But this is what it looks like when it's cut off. Still kind of cool. You look at it, so there's reinforcement. It's hard to see, but this is kind of in a rectangular pattern. I'll talk about that in a minute. And then there's reinforcement that goes around the edges. And and then the drain. And they had the drain that ran right up the middle of the columns. So one thing that we did is we didn't hook back the drain system. I mean, that would have been a little bit more challenging to kind of do drain plans. We ended up just coming in and said, okay, we're gonna rework the existing drains. We built a gravel pad underneath them and said, we're just gonna drop it down for just 6 section, and it really should be in good shape. But here, I mentioned before about the guys that had to get in there and pick away all the concrete around the reinforcement and expose those number 11. Now we were thinking, now you could take off these ties, but the contractor had them on there, and he's like, I don't want to take them off. I'm like, well, that's good, that's fine. It keeps it all together. But they chipped in all around all sides, got it good and cleaned. That's kind of what it looks like after it's clean. You can see the footing down here. So they cut this off where we wanted it, and then they ran their form down and set it right on top of the column, and they dropped the new reinforcement in right down on top of that column. And before we poured it back, we made sure we cleaned it off. I mean, the contractor actually, before he put the form on there, he got out there and we had him pressure wash it, make sure that all the latents was removed. Then we had him wet it back down before we poured our concrete back in. We wanted to make sure that this is a hot mix. You probably all heard that on the news. Everything we're using is a hot mix, Harley strength. And we want to make sure we're trying to control the shrinkage in it. So we want to make sure that core is as wet as possible before we poured it. So these are the columns there along Piedmont. Of course, that was the first part. Now you can see there's still a lot of demo going on, and we're getting ready to get these positioned to pour. So it's a kind of an overlap between demolition and the actual construction. So this is just to kind of, I got a few photos just kind of going through the construction just as it went. And so this is April 6th. We started midnight or even this March 30th. Here it is, April 6th. All 4 columns are ready to be poured at this point down next to Piedmont. And they're still just chopping away at the columns and old caps and removing those. The site is relatively clean, which is that they did a phenomenal job. So 5 more days later, it just keeps continuing to change, just overnight. Of course, they were working overnight. Here we've got Piedmont columns are poured. They've got their bottom form in to start construction of those caps. That's bent 29 southbound. Back over here, bent 30 is already poured. They already have that form in. So in 5 days, we went from that to that. Let me back up one thing right here too. This is April 6th. I don't know if you've seen. We contracted with a company called Ox Blue. And Ox Blue's set up a camera out there to oversee this work. So you can, if you haven't seen it, you just go Google Ox Blue I-85. You pull it up. You can pull a live version up. You can pull up the photos. I got it on my phone. I check it every hour. I haven't checked it in a while, but it was great to see because I mean you could see what's going on and you could talk to people. But anyway, that's 5 days. Yes, sir.
So you put this construction together, there's three dynamic critical paths or per chart, or how does the project management can run, be able to stay on schedule and figure out what to do next?
So as far as the construction goes,
Yeah.
um,
Design work, I mean, because you got to do plans and you got to get those to fabricators to
I did not.
fabricate stuff.
We did. It was pretty. It was pretty fluid. We didn't do any type of. We didn't do P6 or any type of project management schedule. We broke it up in pieces. Steve Gaston, my assistant, and I, we really. I mean, he took a lot, breaking it down in pieces, and made sure that we had people working on each piece, and just kept it coming together. Contractor, honestly, I don't know if he's got he's got a schedule, but not sure how he's keeping track of it. But they've proven that they've done can do it because they've really stayed. Yeah, exactly.
To build on that question, during the detailed design phase that you were fast tracking, was there any point where information came back from the field that you had to do a redesign in order to field conditions?
So sure. I mean, there were a number of things. All right. So I showed you the picture of the cap. No change. I showed you our graphic of the cap, and the original plans had that beam ledge as just one smooth, continuous piece. And then what they had originally done is they'd come in and done little build-ups at each beam. So it was one straight ledge and then build-ups. Well, at some point in this phase, between Thursday and I failed to mention that we did actually get the plans out. We started, Thursday was the event. Midnight Sunday night, we had a full set of plans that we gave to the contractor. So in between that time and that time, we figured out that they built it with steps. They actually built it with steps, and that's what we were going to do. I mean, we were going to build our new bridges with steps, but we were trying to figure out how to handle those existing steps, and come to find out, contractor must back then said, no, I'm not going to build it that way. Let's build steps. So I mean, yes. So we had some things that they would say, oh, let's do this different, and we would incorporate it. Also, in that time, when we got plans out, we had shop drawings, and so everything that we do as a civil engineer, we fabricate it, we get shop drawings back. So in this case, we get beams, bearing pads, metal deck forms, drain system, cross frames. Those are all, we have to get shop drawings in. Well, we were getting shop drawings in Sunday night. And there's a group of us. I mean, we would get them in, we handle them electronically, we'd turn them around, we'd give them back comments, they'd make corrections, they'd send them back in. And what was key, now the contractor was driving us too, because he was saying, okay, yeah, you see that he was building the columns at Piedmont first, but he really wanted to get this bent in here, bent 30, whatever, these two bent, so that they could get these two spans set first. So he went and talked to the fabricator and said, look, I want to figure out, I want these beams first. I want to work my way back this way. And we're fine with that, So we're telling, that's the first set of plans. We're going to send you these beam sheets. We'll give you those two spans. Huh? Good deal. So also, it's hard. This is not a very good show. The existing Dowels, there's a guy coring a machine right here at the core. You can't really see it too well. He's coring out the old Dowels because we want to put those back in.
How big are the Dowels?
They're 1.25 inch Dowels. So this right here, once he actually had to come back in, and right that ramp I showed you before with the trucks coming down, he came back in with asphalt and built it back up because he had to bring an 800-ton hydraulic crane in to set the first beam. Now this set the first beam, this is my birthday, April 17th. You know where I was. So yeah, so he set the first beam, that's a 114-foot beam going in the span. And they went like clockwork, setting the beams in there. In between, you know, it's more difficult than a normal bridge where we just set the beams on top of the columns. They're setting them in between. These are some of the steel diaphragms that we used. This sped up construction. We knew ahead of time the contractors wanted it, so we didn't even bat an eye. We just said, we don't normally do this. We want concrete in there, but we went ahead and just put them in there. And I know he loved them. So these are what the bearing pads look like. Typically the bearing pads are these rectangular ones over here. But because of those skewed spans around Piedmont, we had to have these skewed bearings. And I can tell you, everybody in my office, this is the first time we've ever dealt with the skewed elastomeric bearing pad. So that was interesting. And these are what the dowel pins look like. The dowel pins go down in the concrete, come up through this pad, through that 3-inch diameter hole, up inside the beam. And that's what keeps it on the cap.
So they're steel then?
These are steel, steel dowels. April 20th. We're setting beams. So this crane, this 800-ton crane, is in the middle. We've got about 4 spans that he's setting around there to set the beams all around that side. Now he didn't want to. He wanted to pull, after he gets these set, he's got to get this 800-ton crane out because then he's got to come back and set that span, which is what you see here. It's set at this point, and then you can see the 400-ton crane. This is actually a picture on April 25th. Where this 400-ton crane is sitting out here. It's already set this span, and this is setting the last span. They had you remember that 24-hour closure on Piedmont? It started at 9 a.m. or whatever. That's because we had to have this crane there. And I want to point out something else too. Is this power line that went right across the top, and that worried everybody. I know it worried the contractor. CW worked very closely with Georgia Power. I don't know at what point if they shut that line down. I think for the most part they were trying to keep it energized the entire time. Typically we don't get real close to them when we're working, but they work real closely with Georgia Power. Yeah, exactly. But it's not just the crane. I mean, we have the crane to set the beams, and that was very. I mean, they did a good job. But also when you come back and pump the concrete for that deck, you have to have a pump truck, and that was real concern to get the pump truck to stay underneath those power lines. They had pump trucks sitting up on the end here, and they pump it out. And the pump truck for the span over Piedmont was sitting on the adjacent span, so it was sitting on the northbound span, pumping to the southbound. So decks being poured May 3rd. So this is May 3rd. All the decks are here are poured except for Piedmont, and then May 7th. May 7th, that was yesterday, Sunday. May 7th, it's all poured. All the decks are done. I mean, poured, not done, poured. This is a grinding machine. So they've got a grinding machine out there Sunday that was grinding, has to go in and profile the deck and make sure it's going to ride smooth. And then what they had today was they were out there putting transverse grooves to roughen the surface back. So I suspect they'll be coming back and grinding grooving. You can actually see barrier in there that's been poured. So it's really transformed in a very short amount of time.
Can we get the same crew to go to an 85 or 75 and finish that
The $1,000 question: when is this opening?
It's a good question. So,
Memorial Day.
huh?
At the latest Memorial Day.
That's what they say.
What's your number on the lottery?
Lottery? Yeah, before Memorial Day.
I heard that they were going to begin resurfacing the remainder of this span, a project that was supposed to occur later in the year. Does that happen?
They're well under the way. Yes, they are. Yep.
Already.
That's now that contract was already let, right at the same time, and they just they got the notice to proceed and got them going quicker. So that's phenomenal.
Billy, do you already have this plan somewhat in place for emergency uses?
No.
So this is
You weren't planning on
very
it.
Christmas.
Right.
Well, how late did your son stay there that night?
Well, see, and that's funny too because I don't know. Finally, he stayed out of school. Finally, about 11 o'clock, I said, "Okay, you can take my truck and drive home," and it made it home, and I was very thankful. My son, my son too.
What's your biggest lesson from this whole experience? What's the biggest takeaway?
Well, I will say that now, like I said, I've worked through the 285 fire that we had. I've worked through a number of other large events that we've had. Usually, bridges being taken out, and I was very pleased. We have a very young staff, a lot of young engineers that were involved in this, and they really came together. They were motivated to just jump in there and work real hard, and I think they learned a lot. I hope they don't have to go through this again, but I feel good that they're ready for the challenge.
Well, I know Jason has this question. CW is a Georgia company, right?
Yes.
All the fabrication and so forth, how much of that was in Georgia?
Well, I don't know what percentage. I mean, but
What piece?
the beam's the biggest thing. All the concrete. I mean, Thomas concrete is just right around underneath 85 from there. So, all the concrete I think came from Thomas. A lot of local. Bearing plates came from Texas.
Yeah, only thing is probably out of state.
Mm-hmm.
Were the beams in inventory or were they?
Nope.
Oh no,
fabricated? Oh, no.
all fabricated. Yep.
Everything had to
Into order.
Every beam was a different design.
Yep. And so that means they had to have a shop drawing for every single beam that we had to check, and
Not Legos.
it's not.
Did you consider making a temporary bridge?
So that came up a number of times. So if let's just say it was the one span, the 192-foot span, then okay, that might have been realistic. This hole, once you opened up and we had to replace those 3 spans, the hole was 350 feet long. Now, a difficulty with that is it's not just a hole. It's 350 feet long. It's one end is on a very, very steep skew, and then you've got a bridge that's banking at 4.5%. So yes, it was on the table. In the situation turned out, it just wasn't practical. And you'll notice from the photos too, you saw at some point, you saw the cranes, all the cranes that were up in that power line. If it had been smaller and we could have put something like in there, yeah, we could have had some traffic open, but it would have really impeded the contractor. So I think it's turned out to be the best scenario that we could have chosen.
Well, thank you very much.
We hope you enjoyed this recorded presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at GSPE.org.